decreasing. But what this problem does is leads us into what if you have a number out in front that stretches or shrinks our graph. We are going to use that next. Next, what we would like to cover is what's called vertical stretching and shrinking of your graphs. So let's see how this will work. So vertical stretching or vertical shrinking is when you have a factor that you're multiplying on the outside of your function. And the reason why it's vertical is because it's on the outside. That means pulling it up or pulling it down. So the idea here is if we have, let's say, a function y equals f of x, and then we have a vertical stretch, there'll be a factor that you're multiplying by out in front of your function. So what this will do is either stretch or shrink depending on whether or not the number is bigger than 1 or less than 1. And so normally we don't think about this because normally there's always a hidden 1 out in front of something, which is why when you look at all your major graphs, like the V shape, the absolute value shape, let's see, if we look at that one, the reason why we have a stretch of 1 and there is because there's a 1 out in front of the absolute value graph, and that's why both of your values are up here at 1. Had we actually had a stretch of, let's say, 2, both of our points on either side, instead of being pulled up to 1, would actually get pulled up to a value of 2. We'd have the same x-coordinates at 1 and negative 1, we would just be getting pulled up to 2 instead of 1. So it looks something like this. And the same idea would happen if we had the x squared, the square root, the x cubed graph. We'd be pulling up our points to, let's say, 2, or let's say we even had a factor of, let's say, 3. That would pull up our points instead of to 1, it would pull up our points to 3. Same exact shape. We're still going left and right the same amount. The base still stays the same at 0. It's just your other 2 points on either side are getting stretched up to 3 now instead of 2. That's kind of the idea. And it's because you're multiplying by a number. The reason why, though, that the base point doesn't change, and it won't for any of our 5 major graphs, is because that normally is at 0. So what happens when you take a point that's at 0 and multiply it by a 3 or a 2 or anything is it stays at 0. The only points that will ever be changed by our stretch that's out in front are those 2 other points because they're normally at 1 or negative 1. So when you take a 1 or a negative 1 and you multiply it by 2, it just brings it up to 2. You multiply it by 3, it just brings it up to 3. So that's kind of the idea behind the vertical stretch. So let's take a look. So if we take a look at this first one, the 2x squared, well, the normal x squared graph goes through 0, 0, 1, 1, and negative 1, 1. That's your normal, just regular x squared graph that looks like a U. So now the question becomes, what is that 2 going to do? That vertical stretch? Well, by multiplying by 2, that base, the 0, 0 point, is not going to change because multiplying 0 by 2 doesn't change anything. However, the points that were here at 1, at a height of 1, are now going to be multiplied by 2, so they'll be up at 2 instead. So they're still going to be at the same x coordinates. We're just pulling up the y coordinates. And it's still the same U shape. So our final graph is this one in pink, and that's our 2x squared graph that we were looking for. And that's it. Let's take a look at B. In B, we're looking at the same kind of idea. We are going to start out with the regular x squared graph, which again goes through 0, 0, 1, 1, negative 1, 1. There's our parabola. That's the normal just x squared graph without any stretch. The question on this next one would be, what does the 1/2 do? So what the factor of 1/2 is going to do, because we're multiplying by 1/2, is, well, the 0, 0 point, again, will not change, because multiplying 0 by anything will not change it. But instead of being at 1, we're going to be multiplying that 1 by 1/2, which means our y values won't be at 1 this time. They'll be a little bit smaller. They'll be at 1/2. It doesn't need to be perfect, but it just fattens it out quite a bit. We'll still have the same parabola. It's just that now they're going through, and it's hard to see, 1/2 on each side. They're both still at the right at +1 and -1. Only the y values have changed because this is on the outside of a function. We're only multiplying the y values. The x values don't change. Let's take a look at one more. Let's take a look at C. In C, we've got a different graph this time. Be careful. We've got the square root graph, which is half of a parabola on its side. It goes through 0, 0, and 1, 1. So the normal square root graph without anything affecting it is looking like this, where it goes through 0, 0, and 1, 1. The question is, what is this 1/4 going to do? Well, just like the last graphs, the 0, 0 point, multiplying it by a factor of 1/4 is going to leave it still at 0, 0. The difference, though, is instead of this first point, the second point being at 1, it's going to get multiplied by 1/4. It's going to be even smaller. It's going to be really tiny, a little bit bigger than 0. So it'll still have the same shape. It's just been kind of flattened out and shrunk a little bit. And that's it. So that's our 1/4 square root of x. Best I can draw it because it's hard to kind of guesstimate where 1/4 would be. Okay. Now moving along with D. Let's see. With D, we've got the square root graph again. So we'd start out with the same basic graph going through 0, 0, and 1, 1, which is half of a parabola on its side. The question is this time, what would the 4 do? Well, let's see. We've got a factor of 4 out in front. Well, the 0, 0 point won't change. What will change is the next piece, the 4. Normally it's at 1, but if you take that 1 and multiply it by a 4, it's going to go up to 4. 1 times 4 is 4, so we'll be up at 4 instead. Remember, the x value won't change. It'll still be at 1. We're just going to go up to 4. We're just going to pull it up. Same shape, so still half the parabola. It's just been stretched. On the y-axis only. The x's don't change. Why? Because the 4 is on the outside. Okay, last one. So this last one, we've got the absolute value bars, which means we've got the V shape as our original graph, which normally goes through 0, 0, 1, 1, and -1, 1. Which looks something like that. That's just your normal. I'm not the greatest artist, so bear with me. So you'll go through those points with a V shape. That's your normal absolute value before you do anything. The question is, again, what will that 1/3 do? Well, the 0, 0 point, again, will not change because 0 multiplied by anything is still 0. But instead of the normal y value on the next points being at 1, they'll instead be 1/3 of that because they'll be multiplied by 1/3. So it'll be really tiny, so a little bit bigger than 0, not quite a half. Doesn't have to be perfect. And you'll still have your V shape, so it gets squashed down a little bit. And then that would be our final graph of the 1/3 absolute value of x. And that's kind of the idea behind it. But now what we want to do is eventually put all three of these ideas together, shifting left, right, up, down, and doing the stretching all together at once. Let's take a look at this next couple of examples, which has to do with horizontal stretching. We're not going to go into big depth on this. We're going to mainly look at horizontal stretching that can be turned into vertical stretching, and you'll see why. So whenever you see something that is got a multiple on the inside, that's when you're technically doing horizontal stretching, meaning stretching with the x's because it's on the inside. Remember, stuff that goes on the inside affects your x values. But remember, when we did stuff on the inside, we did the reverse of what's listed. So in this first one, it looks like you should be multiplying by 2. But remember, with x values, we actually do the reverse, so we're actually going to divide them by 2. So you would have your normal x squared graph, which looks like this: 1, 0, 0, 1, 1, negative 1, 1, and it's a parabola. But dividing by a half, and again, we are on the inside, so you're doing this to your x values, will not change the y, so it won't change the height. What it'll do is it'll cut the x values in half. So the height will still be at 1. So the height will still be at 1, but the x values, instead of being at 1 and negative 1 like they normally will be half of that. Will be at 1/2 and negative 1/2. Notice, however, though, the y values are still up at 1. You haven't changed anything with regards to that, just your x values. Let's take a look at one more. So let's take a look at B. In B, we've got let's see what shape. We've got I see the absolute value bars, so we've got the V shape. So the normal absolute value graph looks like 0, 0, 1, 1, and negative 1, 1 would look something like this. And then our final graph here is going to have to deal with the 4 that's out in the inside. So I know it looks like we're multiplying by 4. You're actually going to do the reverse. You're going to divide the x's by 4. So what that means is, again, there'll still be a height of 1, but they'll be in here, the x's, instead of being at 1 and negative 1, will be at just like 1/4. So they're going to be really close. But they're still up at 1. Just like before, the 0, 0 point doesn't change because the x value is at 0. Multiplying or dividing 0 by anything, when you've got 0 divided by anything, it won't change. So that's why, again, notice with the vertical stretching and the horizontal stretching, no matter what, this center point, no matter what graph it was, is not changing because it starts as a 0. Whether or not you multiply or divide it by anything, 0 multiplied or divided by anything never changes. Last one is an absolute value graph. Again, 0, 0, 1, 1, negative 1, 1. You've got your shape, your V shape. The question is, what would the 1/2 do on this last one? On this last one, you are, again, it looks like you're multiplying by a half, so you're going to divide by a half instead. Remember that dividing by a fraction is the same thing as multiplying by its reciprocal. What's the reciprocal of 1/2? Remember, reciprocal is a fancy way of saying flip it upside down. Well, the reciprocal of 1/2, flipping it upside down, is 2/1, which is just the number 2. So what this means is the x values are actually going to be going out from 1 to 2. Again, the y value stays the same. It's still a height of 1. The center point was at 0, so multiplying that by 2 won't change anything. So what it does is fatten us out a little bit. But that's it. Now, the reason why I'm not going over as many of these horizontal stretching and shrinkings when you see a factor on the inside that you're multiplying by is because it's very, very rare. So we know